I made notes so I don't that's no, these are kind of easy, but sometimes you forget. Okay, so let's look at the motion in the x direction. The motion in the x direction has no acceleration. It's not speeding up or slowing down. We're ignoring air resistance. Okay. So we know that the acceleration in the x direction is 0. Okay. We know, just like the little thing I solved for you, that the velocity in the x direction is equal to this. Okay. Remember when we did the thing? Okay. So that means that x equals this. Okay, this position equals this, or you can now when you solve problems, sometimes you'll use this and sometimes you'll use this. And I can't tell you exactly when you're going to use this, and when you have to see what information they give you. Okay, so these are the basic equations how an object moves in a projectile would move in the x direction. The y direction is a little bit more complicated. In the y direction, the acceleration is gravity. So that's what makes it change direction. That's why it goes up then goes down. So we know that the acceleration in the y direction is gravity. Okay? And because it has that acceleration, okay, don't worry about these subscripts too much now. This F means final. The final velocity in the y direction is equal to the initial velocity in the y direction minus, okay, gravity over time. Okay? And we could change this. This looks a little bit different, but it's basically the same as this one. Okay, you'll see what I mean. So we're just changing that to this. This is the same thing we went over before. And okay, so this is equal to that. I know I used different subscripts, but this equals this. Okay, I should have kept it like that, but okay. But to find out the position in the y direction, you need this equation. And there's no need to derive these because they're basically derived the same way I derive the one-dimensional motion equations. Okay, and remember again, you could change this into this. So changing that into that. Sorry about my poor handwriting. Changing that. And again, sometimes you'll just use the v in the y direction, just this, and sometimes you'll use this. It depends on what the question is asking for and what information they give you. Okay. All right. Now, like I said, these equations account for the object going up and down. Okay. But one thing you can do, you can combine the equation you got in the x direction with this equation right here in the y direction using time. Okay. I'll erase all this stuff up here. I'm going to rewrite that equation at the bottom again. Okay. We have this, right? Now, if I can get into a lot of detail, and it could be, 1 or 2 hours worth of I guess, lecturing. I'm just trying to go through these equations really quickly, and I'll try to get some examples. But okay, like I said, you can replace this t using the equation you found before in the x direction, because we know that x equals this, right? Okay, so if we do a little bit of algebra, we can just divide by this right here, and we'll get okay. Now we can replace this t with this, okay? And if we replace this t with this, we will get this equation times minus 2g. Okay, put this in. This is all squared. Now you can kind of clean this one up a little bit, and you can change this into a tangent. See, these v's right here cancel out, and know the sine of an angle over the cosine of an angle equals tangent. So we can change this right here into, let's just rewrite the whole thing. We can rewrite the whole thing to this: tangent of that angle times x minus 1/2 gravity for x squared. Now, just to tell you, I'm throwing a lot of equations around, and I think I'm doing it a little bit haphazardly. I mean, I'm not really, I'm just kind of presenting all these equations, and it might confuse you. And it's confusing at first. You would use certain equations in a certain type of equation for at a certain time or for a certain problem. You can't just randomly use equations. And I'm going to try to do some examples to explain, I guess, on a basic level, when to use what equation. You know, sometimes you would use this equation, or sometimes you need to use the x equations first to find out what the y equations are, or sometimes you need to find out what the y equations are to find out what the x equations are, and it can get a little bit confusing with just a bunch of equations. You know, that's what makes physics so hard, because they're just a bunch of word problems. The last equations I'm going to talk about are the maximum range and maximum height equations. Okay, and for maximum range, that means like distance in the x direction. You know, the horizontal distance. No, would be, I'll say capital R. It doesn't matter. Just capital R. Now, okay. This equation will get you the maximum range of how far something will go at this angle and at this velocity. Okay, and actually the maximum range you'll get is about 45 degrees, I believe. You also can use this this equation too. It depends. Like I said before, it depends. Okay, these are for maximum range. Sorry for my bad handwriting. Okay. Now, the equations for maximum height. The equation for maximum height is okay. I'll just write y max instead of y max. Is equal to, and as you know, the sine of any angle. Well, of course, if you fire something straight up, you know, that's going to give you the maximum height. So if this is 90 degrees, you get the maximum, you know, maximum amount of velocity. You know, using that that kind of, you know, the angle of, you know, fire, the trajectory, the angle trajectory of the object, that like the cannonball that's being fired. So yeah, these are the equations of projectile motion, and I don't want to be so equation-y or using so many equations, but those are the things you need to know, and you need to be able to play with those to figure out what you need to know in projectile motion equations. I'm going to do a few examples just so we're all on the same page, at least on a basic level of what to do.